All right. I'm going to get started then. Um, Adriano,
Hello.
hi. You want to act as um, someone I can talk with, so we can try and focus this a little bit.
Yeah, no problem.
Great. Okay, so today is going to be sort of a basic introduction to some of the tooling I've been working on, and the idea is to first of all show what I've done so far, and then um, once once we have an overview of the technology, then we can start in coming week a bigger discussion about the more of the details of the concepts and so on. So let me just get started in terms of showing some of the technologies and concepts, and then I wanted to sort of keep things more open, have an open discussion, and then see how the next weeks are going to be structured, where we can talk about various aspects in more detail.
Okay.
All right. So, um, so over the years, I've been motivated to work on a development system where an individual developer can build out a system, a complex system, and a common problem during web development is when a project grows from a simple project and gets larger, the number of components and the complexity of the project increases, and it becomes increasingly more difficult to organize and maintain the system as things grow. So my motivation along the years has been to work on developer tooling to help developers work on multiple systems, switch back and forth between systems, components, collaborate with other people. What are the development processes? How does that tie into the developer tooling? How would you have to design a system for those kind of flows to be easily supported, and so on? So the one of the main important points is organization of your workspaces and your code on your desktop. So when you are developing code, it's important to structure code cleanly and in a way and document it so that when you come back to it later, you can pick up things right there. Also, to have things structured cleanly and to be able to install dependencies for your system and so on easily, you also have to be able to, you also want to be able to share that with other people. So the development system takes care of all those things. So let's get into a little bit of the detail. So by default, okay. So we create a workspaces directory, and we can create a workspaces directory anywhere that contains various workspaces that you want to sort of keep together. So I have a workspace directory, I have my system project, and the system project, now we're going to go through a little bit more detail about how it works and how the services can be deployed and so on. So here we have io.devcomp. That's actually the site that's running here. So today is the first day, and this is going to be all a little rough today. And then as I get a little bit more practice in the coming weeks, I'm actually going to be developing the devcomp.io site and system and the collaboration system that we're talking about. I'm going to be developing live over the coming weeks and throughout the rest of the year. So the idea is that we have weekly discussions, and we touch on certain concepts and ideas, and we decide to, okay, we want to integrate a certain piece of technology into the stack, and then once we have integrated the stack, once we've integrated the component into the stack, then we can take we can all use that feature within the development system. So, okay,
Okay.
let me back up a bit. Okay, so here, devcom.io, that's live system. So we're now going to develop and look at how we're going to build this development system a little bit. So when you start a project and the way this site is built, we have a project called devcom seed. And devcom seed is your system seed project, and the system seed project has a few files in it that should look somewhat familiar. So every system you work on has this basic structure, and within package.json file, that's simply an npm package, and we declare a installer in the package. That's part of the bootstrapping. If you look at install.sh, you can see that it installs the npm modules, and then, oops, and then later it calls SMI install. So SMI is a new package installer that I've been working on, and that I'll get into much more detail in further weeks. It's basically takes npm and takes it to the next level. So it adds a whole bunch of features that are really missing out of package managers to be able to compose packages and dependencies from arbitrary resources. So this package manager is going to be is an integral part of the stack, and as I said, I'll get into more detail with that later. So SMI install installs all the dependencies. So SMI install looks at the pio.json file. In this case, so here. So in the package.json, so everything. Okay, I'm realizing that it's really hard to focus this talk, and it's going to be a little confusing at times. And I think we're going to use this first week more as an exercise, just to get an overall picture, and then we can get more targeted in future weeks. Okay, so
Yeah, but by now it's okay. Like it has the dependency about me, and SMI now has
right.
the JSON in use. So
Right. So
yeah.
when you interact with a package, the first thing that gets read is a package.json file. In there, you can have further configurations, and you can configure certain components. In this case, we configure SMI to look for a descriptor in pio.json. So anything that's relative like this is relative to your package.json path. So this is a convention that is used throughout if you want to reference things. So this reference is now pio.json. So SMI will, based on this, then look at pio.json to look at further dependencies to install. Okay, so
Right.
pio.json is your main file of interest, which sort of bootstraps the whole system together. So the first thing you see is okay, so this JSON is its own language, and I'm in the process of defining exactly and wrapping that into a separate project, the exact language of all the features of this. And there's a lot to this, and this needs weeks to cover in itself. So I'm just going to touch on some of these concepts very briefly. So the idea is that the pio.json file, and pio is a new command line tool that I'm open sourcing that deals with system development. So we have pio.h. Oh, wait. One sec.
Mm-hmm.
Okay, pio.h. So from pio manages the basic life cycle of services. So if you look at the commands, we can list the services that are in a system. We can deploy a service. We can see info and status about the service. We can test the service, publish it, start, stop, restart, and a few other commands. So when we when we have an instance, we can see different services that are on the instance. We can see the group the services under, and then we can see host names and other ways to access that service. And this is just a basic start.
Mhm.
Okay, so the idea is you have a development system, and the development system declares multiple services, and these then get deployed onto the instance. So, okay, so pio.json. This structure, we can see a service here, io.devcomp, and if we look at services, devcomp, io.devcomp, we can see a service declared here,
Mhm.
and that's a service that gets deployed. Now, under services, there's only one service deployed in this instance of the pio.json file. And that's important because the way the system is designed up, it allows you to inherit configurations from upstream. So we are, in this instance, when we're working on and going to be developing this devcomp.io site, we are defining our dev instance for the site here. And in the dev instance, we are extending the descriptor for another system. So in this case, we're extending a descriptor called OSInception profile source profile.proto.json. This file is a pio.json file with various properties in it, just like this. And when it gets referenced here, our properties get merged on top of this file here. So you can have infinite nesting. You can extend multiple upstream descriptors, and you can layer them here. And again, that's where some of this specific language comes in, and how this JSON is works when it gets overlaid and so on.
Mhm.
So to know where OSInception profile is coming from, we have to declare in this paradigm of SMI, which interprets the structure. There's no dependency that comes from anywhere without being mapped, and that's really important. So first of all, we map certain upstream packages and catalogs. So for our system, we're saying that upstream, we have a catalog, and we have a catalog that we want to map to OSInception internally. So we're declaring a catalog OSInception internally. We're defining where that catalog is coming from and the authorization code to access that catalog. Now, this catalog is being served by another instance of this system, and this system that we're building here can publish its own catalogs with its own components so that any instance can then publish its own services and its own catalogs, and you can pull in services from anybody else using this cataloging approach. If you want to splice in developer packages, you can link packages like so. So this OSInception catalog installs a bunch of packages into your dependency tree, and I'll go into that in a minute on how that's laid out. And then in development, when you install this in development, you want to overlay some of these packages. And so instead of downloading and installing the sources from the remote source, if you have the sources available locally, you want to link those packages into your working tree, and then this is what this is for. So for the OSInception catalog, I can say that I'm looking for any packages I find in this directory structure. I'm going to map those packages automatically to OSInception, which so this is then the mapped catalog. So this here is mapped here. So this is a prefix, and again, I'll go into this a little bit more detail. If you're familiar with Node.js requires semantics, the first term can be used to reference a package, and this is the same way. So we're referencing a package here. We're mapping the package, and the package is mapped to the OSInception catalog and the OSInception profile package. And
Right.
that's how this whole thing is resolved. That's for So this is how you can get arbitrary dependencies into your tree, and this is very flexible, and pretty much all you need to get your dev system up and running. The next section is you can have additional configs, and here we're configuring additional pieces of the services. So the PIO service is the PIO are various services used to provision a developer instance. So PIO is actually a system that now takes this um, this configuration file and provisions an actual VM from it. So by minimum, to provision a VM, you want a domain name, you want a namespace to use for all resources and services that are going to be on that domain. You want a key to use for your instance, and you want a service, a repository. In this case, I have an S3 repository where the system is going to cache all your services and built assets and catalogs if you're publishing catalogs and so on. So once you work and develop systems using PIO in this way, you don't need GitHub or any other outside resource to start collaborating. You need your own asset repository and a way to serve your own catalogs, and then people can start consuming your stuff without you having to publish to GitHub or any other third-party source. And that's really important in terms of the dev workflow. So you just create an instance and you're ready to start publishing sources for other people to consume in packages. The next configuration, pio.vm, we configure an AWS VM. So the user's Ubuntu. Here are some configurations for AWS. No need to go into that. For DNS, I'm going to use a service called DNS Simple to automatically provision DNS for the instance. Here I have a little config to configure the catalogs I'm going to be publishing from this instance. So I'm going to be publishing a DevComp catalog so other people can consume components from this dev system. And then down here, we start configuring the services. So if we look at one service specifically, and that's what I want to go through now, if we look at the DevComp service, so here we have the site, devcomp.io, and that's the part we're developing. And here we declare this service. So we have a group called devcomp, and the grouping for services are more for just organization purposes. If you have a lot of services in your repository and in your system, you want to start grouping things. So this is more of an arbitrary name. What's really important and needs to be unique within your system are the IDs you choose for the actual services that you deploy, which is these services here. So if you have a command line tool that you choose that you know, if you have a name, a command line name, or a name, a Unix name, or npm name that you know is globally available, and nobody else is going to be conflicting with that, you can choose that name. If you're not so sure, and other people could be conflicting with your namespaces, then use reverse URI namespaces, and that way you'll never conflict with your services. So we declare the service, we define a port, and then we can define certain plugins. And we're configuring a plugin here. So we're, for the devcomp.io service, we're configuring the PIO proxy plugin, and here we're declaring that the proxy that's going to be running on this dev instance, we want to proxy devcomp.io to port 81 internally. And I'll get into way more detail on how this stuff works in more detail in the coming weeks when we look at things sort of section by section and service by service. So we can configure the plugin, the proxy. We also configure our internal admin server to proxy an arbitrary host name that's always available in your instance. So that these are these host names. So as soon as you deploy a service that's on a port, it becomes available, and you can start referencing and calling it without actually having it any other vhost for it. And as you can see, it's just it prepends the ID here, or it's whatever you configure here. And then finally, in this
Okay.
case, we are configuring DNS. So for DNS, we're configuring these records. So devcomp.io, start at devcomp.io, domain.com. So if we now look at this service and the implementation of this service, um, here's the source repository from that we've cloned here. So here we have our own local copy. And let me just show you. Okay. So here we have our basic repository. Now, when we, to install it, we just call install. And what you'll see is, as this goes through, it installs the SMI installer. Then it calls SMI install. It goes ensure upstream catalog. Is the catalog found? If it's not found, we download it. So it's going to contact the catalog URL that we found with the code, download the catalog, and then once the catalog is downloaded, it's going to ensure all the different packages. Now, if the packages are found locally, it automatically symlinks them. So we can see skip provisioning package, symlinked, and so on. So it's going to find a whole bunch of packages for me and symlink them locally because I have them available, and then complete at the end. If you install this, it's actually going to provision all the packages from the catalog, from the S3 for you locally. Now, what's really important in this workflow is that when you're working on the system, many times all the components on the system are a complete black box to you. You have no idea what components are running on the system. So the idea is to provide complete transparency in terms of what's running on your system. So if you look at now that we've installed this and we refresh our folders, we can see a couple of things here. So pio.json, we have an extends declaration here, and that gets resolved, and you can see right here what configuration gets pulled in. So pio extends, and we can see the upstream configuration that was getting pulled in right there. So it declares a couple more upstream packages to link automatically. Then it declares various mappings for packages that need to be installed locally when you install the system for development locally, and so on. So this is a descriptor. Again, this comes automatically from the upstream catalog, and it's just linked here, and it's placed in relation to the file of where it's being included. So you as a developer, as you're developing, it's very easy for you to go through and see where your configs are coming from. On the catalog side, during the installation process, an upstream directory was created. And in the upstream directory, we have our catalog file. So this is the catalog file that was fetched from the upstream server that has all the assets in it. So if you look at the catalog file, it has a name, it has a unique ID, it has a revision, and then it has the packages. And then the packages are the unique IDs of the packages. The alias names, the unique names of the packages within this catalog. So each one has a unique ID, checksum, timestamp, and then most importantly, it has several aspects of the package. So a package is not always just built source or source code or whatever. A package can have multiple aspects, and in this case, a package has source and it has scripts. So the source is the source code of the package, say a Node.js web server, and scripts are some of the management scripts to then get that web server running. Other aspects may be issue data or additional metadata for the packages, or you could have compiled source and raw source or optimized source, or it doesn't really matter. During the publishing process, you can hook in different builders and build various different aspects of your packages for different catalogs, and that can be completely configured, and you can manipulate the packages for the different catalogs however you want to prepare them for consumption from a user. Also, the catalog can override descriptors that are contained within the package. So if you want to configure the package in a certain way, if you want to pull the package from somewhere else here and then configure it in a certain way, you can override any of the configurations here. And that's essentially the catalog file, and it declares all your packages. And then a little bit further down, It declares additional environment variables and additional configuration information that is by default needs to happen for all the components that are pulled in from the upstream catalog to function. So in the VM, we can see that it's doing a few more things. So we're defining a security group, opening certain ports. When we provision a system, we provision certain services at minimum. We have some more DNS records so that the basic host name gets automatically resolved. And then for the command line tooling, it declares certain plugins that get loaded when you run the command line tooling, and so on. So the point here is that everything comes down to configuration, and configuration is very important, and it's a big part of this system. So once you have the catalog, then it goes through and provisions all the packages for the catalog. So in OS Inception now, here you can see all the packages that have been downloaded, and in my case they're linked, and if you download this, all the package sources would be here, and if you look at the packages, you can see the source and the scripts and so on, and get look at the detail. Looks like there, and so on. So all resources, all code that is on your instance and going to be running on your instance is instantly available for you to review and look at. And you can make modifications here in your code, and it'll sync those to the service as well. So that means you can make changes to upstream packages as a hack to get things working, upload those, and sync those to the server. Okay, so that's all to do with the upstream packages and so on. And now we can deal with specifically the services we're developing for this specific instance. So we were talking about the devcomp.io site. So devcomp.io, the way this site is built, it's going to be using some of the pre-built features that are going to be becoming part of this dev system, and I'll go into these in the coming weeks. So here we have io.devcomp, and at a very minimum, we have a package.json file. It's an npm package, and we define a certain converter to use during deployment. So we call PIO deploy converter, and we're saying that we are a Node.js server package. Now, this kind of stuff can get detected automatically and will down the road, but the point is that the automatic detection will generate the configuration, essentially mark up this configuration, and then the configuration will be used to actually used by the tooling. So this is any way to automatically detect things about the package is just a matter of the automatic detection will create additional configuration in this file and overlay it more internally, more dynamically internally. Okay,
All right.
so we define a converter. Once we have a converter defined, we just need a server. So here we have a simple Node.js server from the Node.js site, and you can see here watch live 10 a.m. to 11. That's what we have up here. So if we now say watch live, and we say on now, save it, and then here we go PIO deploy io.pio, io.devcomp. It will see if the source has changed, and then convert the package. Based on the converter, it converts the package, rewrites certain script files, and so on. And we can see what gets converted and what gets created in the PIO sync directory. And again, this is another stopgap for you to see exactly what gets synced up to the server. So the idea is that you have all sources locally. You map them into your local space using the upstream catalogs. Then you have all your sources locally in your tree. And then when they get synced up to the instance, you have an exact copy of what gets synced up to the instance. So in this case, we have io.devcomp, and we have two things that get synced up. We have scripts that get synced up and source that gets synced up. So .pio.json is our config file that gets prepared for the service to use online. And then we have the source, So that's simply a copy and potentially a slight manipulation of the source originally. And then the scripts are, in this case, generated by the converter. And there's a few things, say the post deploy script, which is the first script that gets called, calls PO to post deploy. And then PO to post deploy has a certain workflow that it goes through, which goes through a build, configuration, installation process, and then runs the service. And in this case, it runs the service by just starting, creating an init job, and then starting it. Restart, yeah, see. Okay, so that creates an init job. Now, when we go further down here, we can see that what happens is it replaces variables, installs, configures, and deploys. So when we actually look at this structure online, on how this directory structure looks on the server, we go to OPT, everything is put into OPT, and in OPT, we have OPT services, which are the services that get linked up. So we have io.devcomp, that's the service we're just discussing. So there's a few directories: built, configured, live, prepared, synced. So in whatever gets synced up is in sync, and that's completely in sync with what's in your local cache here. So again, this is exactly what gets synced up, and then this is what lost my terminal. This is what in sync is what gets synced up, and then it goes through a certain build process. And the idea of the build process is to allow several layers of caching before the resource actually gets linked live. So it goes through, first of all, a preparation stage. So it copies everything from sync to prepare, and after it's in prepare, you can run certain modules over it to modify the source. And this is important if you need to like dynamically patch things, or you can do certain things to manipulate the source, especially if you're pulling in third-party sources and you just want to sort of convert a few things or apply a couple of patches or something like that. That's all, again, gets done in the prepared stage. After the prepared stage, it copies everything to the built stage. And in the built stage, everything gets installed. All the dependencies get installed. But what's important is that during the build stage, the idea is that the build doesn't hard code any paths or any variables or anything for good. So there's many scenarios where, say, you have to compile C code, and there's certain flags and prefixes and so on. So that needs to be split up, and it's a common scenario where you want to compile something for a certain VM or a certain group of VMs and so on, and once the asset is compiled, it is usable on a certain set of environments. And the way that's handled is you can have a configuration that configures the build. The configuration gets checksummed, the build gets made, the build uses that checksum to create a cached asset, and then when anybody else that has a compatible environment uses that package with a compatible configuration, the cached build is automatically downloaded from S3 instead of recompiling everything. And this is very important for compiled sources that take a long time to compile. So once things are compiled, then things move into the configure directory, and then in the configuration aspect, then if there is additional compile steps or additional configuration that needs to happen that is very specific to this instance, to this deployment, that's when it can happen now. So the general build is done, then the configuration step happens, and after the configuration step happens, the live link is simply a link to where the configured service is. And here you can see the checksums that get created for the different things. So this is the sync checksum, the build checksum, and then the configured checksum.
Okay.
if anything fails, if the build fails, it will not go live. It will the build will fail, and you will get a directory with the build failed, and you will get all the resources and everything that happened up to that point, so you can exactly troubleshoot what happened during the build failure. You'll also get feedback in the deployment here, and if anything fails, you can fix your code and simply redeploy until it succeeds. And then once it succeeds, it'll actually go to link live. Okay, so that's it from a deployment perspective. And if we, okay, so then the other thing is logs. Well, logs gets automatically created based on the converter that we're using. And these are just access logs for the server. Okay, so now we've deployed a service, and we have, and that's the process. So we deployed it, and we did that before, so now I deployed it again. Nothing changed this time, so it skips, and I'll go into a second how it checks how it detects the changes. And if we go on the live site now and click refresh, we can see the on now we published earlier. Okay, so when you publish a service, there's a file called .py.file list. This file list gets generated when you publish a service, and it includes a list of the files that were published and timestamps and potentially other information about the file. So this information is used to then detect if sources have changed. So based on all the services that were published, we can now do source change detection to see if the relevant source files that actually did make it up to the service, if we modify any of them locally, we know about it. So in this case, we deployed PO deploy, didn't find anything, and it didn't deploy. So this comes in handy when you say PO deploy, and the common scenario is when before you start development or you don't know what the status is, you go PO deploy, and you deploy all services. So it's now going to go through and just check all the services to see if everything is deployed. And unfortunately, there's a little bug here right now that just cropped up while I was fixing something this morning. So we can't actually run it through. But the idea is that it'll go through and only deploy what actually needs to be deployed. Okay, so in addition, the next most important, or the next interesting part now is, because we have the sources here locally, we can check what's there, we can check the files that are there, we can now call something like pio.spin. And pio.spin will, and I think this may fail too, yeah, because of the same reason as before, but this is the idea. And I can show you in a different instance. So it says watching 918 files for 16 services. So it just went through, read all these files, and is now watching all these services. So what's important to note here, we're not watching all the dependencies, we're not watching all the files, we're not watching most files that never get changed. We're only watching our assets that we have published and are editing or could potentially change. So if you start modifying upstream dependencies and so on, you would bring them into your service, into your system, and then it would start detecting the changes, and it would start tracking the changes, and so on. So you can see how having this kind of metadata available now opens up a whole lot of things in terms of being able to sync code more dynamically, and that's the point. So right now we're always syncing code from your local dev workspace to the online instance, but now it's very conceivable, and the direction it's heading is where we're going to have a more complete change management system where you can make changes online and they'll sync locally, or you make changes local and sync online and so on. And we can really go any direction we want there. Okay, so PO.spin will upload the service. So I'm going to show you this on a different service since this one isn't working. So OS Inception is the upstream service that we're going to look at now, and it has a few more services. And here you can see the services that I'm working on. So all the different PIO basic services, and then I'm going to be add various sort of foundational services that can be used to sort of compose systems very quickly. Okay, so I want to show quickly the automatic sync. So here we go, PIO spin. So based on, it's going to go through and see if any changes are there, and it found a change in DNS. Okay, so now it's watching for changes. Um, Actually, I'm going to show you on the admin system. Okay, another thing. This dev system comes with a built-in admin system. So if you go PIO open, it goes to the internal server, and then it initializes an admin system, and this admin system comes stock with all instances of this system. And this is really the sort of core part that I'm going to be making lots of headway in the coming weeks, which is now going to surface all this metadata and surface all these relationships and documentation and so on. And you can see here, it's already pulling in a dynamic list of services. So the idea now is to build out this admin to allow you to look at the documentation of the service, create issues, link to GitHub, have a GitHub login as part of this admin, and so on. So I'll be building these things out bit by bit. And once it's all working on the core instance, then it'll work on the developer companion instance, and anybody else that's using this dev system as an upstream resource is going to get all these features and in this admin system and everything automatically. And the kind of way I want to do it is I'm going to have different sections on the left here that you can click. It's always going to show all the services on the right, but show different aspects of the services. So say licensing information or contributors or dependency information or who's using what, or I mean, it's really endless because we have a ton of metadata available of what we can do now. And okay, so here we have the admin. So now say we want to work on this admin. And again, anything I do on one instance works the same on all instances, and that's the whole point. So if we now go here, pio.spin, and we can now see it's watching files. Okay, so now we go to IO, www.lib, widgets, and now going to some of these, I've built a little widget system that will play nicely with web components. And once I've built this out a bit more in the next couple of weeks, I'll document this a lot more, and it can be really used on the instance. And all this entire admin system is going to be built using these widgets. And the idea is the widgets are just HTML elements with a bit of JavaScript, and they can have dependencies declared and mapped and all this kind of stuff, just like anything before. And they're simply included. So it's, say in the body, you have a body here, and in the body down here, I'd say div x widget, give it a service ID, give it the group name, the service ID, and then that will insert the widget here, and you can sort of compose entire UIs by inserting widgets from different services. Each service can declare widgets, and widgets are, I mean, they're really simple. It's just HTML and a bit of JavaScript. Very powerful to start having interaction with your service. So in this case, in this widget, in the client JavaScript, it goes to service online to fetch more information, and this service part for this widget is simply a simple Node.js app, so a simple connect app that dynamically gets loaded into the widget server on every request. So we can make changes here, and they automatically get synced up, and then we just click reload the service, and the change comes through. And again, okay, actually I'm not going to go into that more. Okay, so let's do a quick example here. So we have list, okay, and then we're gonna say hello, like that, click save, and as soon as I click save, it detected the file. Now it's syncing the file up and restarting the service online, and now I just need to click reload here, and we should start to see the hello right there. So what it did was we can look at the logs tail io.pin. Oops, sorry. cd logs tail inf.ui log. Okay, so so that's our online log here. That's our local sync log. Okay, so we click reload here. We can see the requests coming through. Or not. Oh, I must be on the wrong server. Yep, I am. Sorry. That would do it. I was wondering why it didn't move. Okay, so we'll copy that. Go in there. OPT logs. Tail. All right. So click reload here. Okay, see a request come through. Down here we say PRS spin. It detected the change we had before because we haven't synced. So every time you call PRO spin, it automatically will sync all the sources that have changed since your last sync. And then here you can see it reloaded. So if we now modify this again, hello world, save, detects it, calls online to restart the service. Here the Node.js server gets restarted, and then the change is live. Now, this kind of process can cascade into many layers of your application. So in this case, it's very simple. We make a source change, the source gets synced, the Node.js server gets restarted. That's sort of the basic scenario. The next parts I'm going to be working in is I'm going to have a sort of little client UI framework that will detect if the server restarts, and if the server restarts, any affected widgets that were loaded by the UI are automatically going to reload in the UI. So as I make a code change here, I have to look at the UI, and widgets can get swapped out in place. So we don't have to, the way widgets are going to be loaded, they won't conflict, and you can have multiple versions of the same widget running in the code. So as soon as you make a change, that individual widget in the page will get reloaded, and any child widgets that widget will load will automatically reload it in the process. So as you're then making changes, things update in here. And the idea is to not have everybody use this widget system I'm building or anything like that. That's not the point. The point is to illustrate and show the concepts using this devcomp.io server and this dev stack I'm building. It's all open source. We want to document all the different components, and we want to show people how to then integrate this development system into their system to, at a very minimum, allow the server restart as I just did, or then in more advanced way, allow components to restart when server things change and so on. And that's yeah, so that's pretty much it. So that's sort of a really basic overview of of the system as a whole, and now it's going to be a matter of really going to a lot more detail about different aspects, how things work, and I will now, over the coming weeks, be continuing development on this system, updating the site, updating the information, and start developing this devcomp.io site into a site where you can clone the entire system. So it'll be simple instructions, and I mean it's pretty simple now. I just have to sort of put it all up and finish the documentation, but it's a matter of you need Node.js, you need a dedicated AWS account, you want to create a workspace directory, you want to have an activation file that configures certain credentials for you that live in the workspace directory. And then, so in this case, we have io.devcomp.activate, and then parallel to that, we have the io.devcomp workspace, which we clone. Then you just roll install, you source this file and a few other things. I'm using this. And then you can go PO deploy. And if you haven't deployed anything yet, it will go and deploy it. So as an example, just to show you what happens when you deploy something that wasn't quite provisioned yet. So if we go to devcomp here, we go pio deploy io.devcomp like so. Okay, nothing's changed. Now if we go into pio.json, let's add another DNS entry here. Okay, so we want to let's go learn.devcomp.io. We want to map that. Okay, so I run that, go PO deploy. No code change, it doesn't change the config change yet, so I just have to force it. But as it deploys now, it should actually do the DNS provisioning, but it's not. Again, I don't know why not. I must have just messed something up this morning. Okay, anyway, it was all working. So the idea is you make a config change. As soon as you make a config change, the system updates. And with the PIO spin, the PIO spin is all you need to do. So when you get started, when you work on a system, and you want to do work on the system, all you do is you go PIO spin, and that will take care of getting everything up to sync on your dev instance, and you can start developing. So once that finishes, you should be good to go, and you should be able to go up and develop. So once POS spin is running, any change that gets made should automatically get reflected live in the live system. And it's pretty much working that way, but that's how it's going to work. So it's 11 now, but if there's any questions, I'd like to just go through some questions, and then we can wrap it up. And maybe we can look at what should we look at first as a more in-depth focus next week. For me to start documenting more and allowing people to get involved in this. So if there's any questions, let's hear them.
Okay. So how should one start using the tooling? Where to go first?
What's that, sorry?
What to do first? If I want to start using the tooling, for deployment, where to go and how to start?
Okay, so I'll update devcomp.io in the next couple of days to include everything. Well, it'll probably be working later today, but it'll have next couple of days. It'll have all the instructions needed for you to actually run your own install and try it out. And it's all there already. I mean, you can try it, but this is the instructions are going to make it a lot easier. So I'll have those up in the next couple of days.
Okay.
And it's going to start with cloning it and deploying your own instance of this devcomp.io site that we're building. Where is it? Yeah, this.
So it's going to be easy as calling PAO deploy.
Right. And
then
it'll
for
go
every
live.
change, PAO spin.
Right.
Yeah.
One
Very cool.
PAO spin, and then you can start making changes, and then things will go live.
Very cool. Well, that's it from me.
Do you have any questions, Chris?
No, not as yet, Crystal.
Okay.
I'm curious how this is broken up into individual components.
Yeah. So we can so what was important to me was that I could start a dev instance from scratch without needing sort of any third-party tools or anything like that. So the pi.json, the VM gets first provisioned, and as the VM gets provisioned, it checks for certain things. So let me actually devcomp. Okay, one sec. Okay, I'm just going to configure one thing here. Okay, so I just reconfigured my one server to use new credentials, and we're just going to create a new stack. Okay, so we're in here now. So we go rm pio.rt. Okay, now we can go pio.ploy. So I just changed the credentials, and now things have changed. So now it's going to try and I have to change one more thing here. Install. Okay, so exit. Bin activate. Okay, so now we can go PIO deploy. So, so it creates a VM. It goes to AWS, sees that nope, there's no domain, there's no VM. So then it goes so based on certain config information, and this is in learn. Okay, so here we have a few things, a few config information here. So we have PIO epoch ID. So this is sort of a root ID that everything gets based off. Then we have a few more IDs, and the idea is that these IDs help you create namespaces. So namespaces get derived of these IDs, and if the seed key is the same and not the user ID, you can derive different namespaces and so on, and you can attach different data stores to different namespaces and so on automatically. So here we're creating an automatic ID for the server based on this information, so we can always identify the server again. So we first create a URI for the server, which identifies the server, and then it goes to AWS and checks to see if it's available and so on. So the server isn't running, so then it creates a security group, creates the ports that are declared as in security group, it uploads our SSH key, and then it creates an instance. So then it waits for it to boot, waits for SSH to come up, and then once port 22 is open, then it starts to provision. So here with provisions to DNS, so it automatically points the DNS records to the new VM we created, provisioning DNS, and then it goes in and actually starts provisioning the different services bit by bit. Now, when the instance first comes up, it's a complete bare metal instance in this case. So in a bare metal instance, it starts in pio.json. We can see under provision, the first thing we deploy is pio.server. So pio server is the first thing that gets deployed. So under pio server, we can see we have a post-deploy script. And in the post-deploy script, we are now bringing the server up to speed to start receiving calls from our system. So we install Git. We essentially mimic the way the directory structure gets manipulated when things get installed. And in this case, we install Node.js, we install Mon, which is a little process monitor, we install our launch script, and then we're done. So this installs a Node.js server with all its own dependencies. Nothing else needs to be on the system. So once the server.js is installed, it opens a socket port that the client tooling can connect to. So the command line tooling here, by default, if there is no PIO server on the instance, will use SSH to tunnel into the server and run commands and so on. And then as soon as the PIO server is deployed and available, the command line tooling will use it and create a socket back channel, which can then run the commands through the socket. So you drop the latency of always creating SSH connections right there. Once the PIO server is on the server, we can communicate with it more directly. And then there's a few more things that get installed to sort of ease the process of, developing, of having more advanced services. So then we go PIO post deploy. So the PIO post deploy is the command that most services call when they get deployed. And in post deploy, we simply again install. It's actually command line. We install a command on the server, PIO post deploy. So once the post deploy is installed, then the other services can use the post deploy to then deploy themselves and thus provide less sort of scripting and scaffolding to deploy themselves. So the PIO in this case can now start using this stuff. No, this stuff is already used, but this converter, for instance, Node.js lib TPL scripts post deploy calls PO post deploy. And the PO post deploy has a bunch of default scripts that get called, and you can override them. So in this case, for Node.js lib, we're overriding the build script, and we're calling npm install and linking dependencies and so on. And so at a very minimum, when you declare a service, the very least you have to declare is a post deploy script. And then you can opt to go further deeper into the system to use some of the existing features that would come part stock, or you can write your own. I mean, you can deploy your own command to call on post deploy or whatever you want. And there's lots of metadata available in these calls. So it's installing everything, but there's lots of environment variables available to help you manipulate and do things in these post-deploy scripts. So one of the first things I'm going to be doing now is to document this a little bit more and then show which variables are available when and so on, and put that all into the documentation on the instance. And that documentation will then come with the instance whenever you update to the next catalog.
All right. Well, thank you. That's a good overview. And I presume we're on tomorrow still.
Yes, that'd be great.
Okay. Well, I'll try to think of where to
Well,
go from here.
so tomorrow, you and I hope to talk about the um, certain things in more detail. I mean, yeah, you can give me an overview of the kind of stuff you're working on, and then we can see um, the aspects that I'm really looking for um, to make more headway is on how all the JSON configuration is managed and synced and so on. And there's
Mm.
certain primitives that I want to discuss that if we get those right, it's going to allow us to build very powerful abstractions with very little code. And I'd like to factor all that stuff into this code base I've started.
Mm-hmm.
And so what I've done is everything I've presented today, I wrote in the last sort of 3 months. And the point was over the last couple of years, I did a lot of work on a lot of foundational libraries that that deal with the various concepts in detail and have unit tests and so on. So all these libraries I've built over the years, they all deal with specific concepts, but it was too difficult to build a system such as I presented today out of these primitives right off the bat, and I've been struggling with that over the years. So early in the year, I decided to start a second stream of development by hacking a system such as I presented together using this PIO service. So everything in this code base is captures all the concepts that need to be there, but the code is written at its bare minimum, and you can actually sort of follow the flow of the code without too much abstraction.
Mm.
And the goal now, between now and the end of the year, is to refactor this code bit by bit and factor in the primitives that I've written over the years to provide all the advanced metadata, to provide more of the advanced abstractions so that all the things that are not nice in this first implementation that can be abstracted into common libraries and can be made nicer. All that's going to happen in the next between now and the end of the year.
Mm-hmm.
So that's why I wanted to start discussions, because once I start getting some of this metadata available, it's going to get, you'll see of the volume of information that's available, and the whole point is that you have a dev system like this where you have all these packages. You have your packages locally, so one of the first tests you have in terms of how you encapsulate your packages is you know if your packages are properly encapsulated once you start publishing them and running them in different environments. So this dev system is a good way to provide a first solution for that, where your source is local, it syncs online, and online the packages are arranged slightly differently on the instance, but mapped with the dependencies so they still work. So that's the first step. When you then publish a catalog and someone else installs it, that's another test to make sure your packages are abstracted properly. Once that is the case and we can remap dependencies in arbitrary ways, we can then use this dev system and build a scraping system that will, based on the metadata, then pull out the sources and optimize them based on whatever builds we need for the system.
Mm-hmm.
And that's the idea, that you have this base system where you have your source code, you have all available metadata, and then you can run tooling over it to pull out source either in real time or in batch or however you want to compose your optimized runtime bundles or your builds or whatever in whatever fashion you want.
Yeah.
And that's really the point. And once you have this working on one system with an integrated admin system that everybody starts up with when they start the instance, and everybody has everything I just explained available by default, then you can really start looking at the collaboration features and the community features, and then how do you tie all that together to sort of have the collaborative development and so on. And that's sort of the overall plan.
Okay. Well, tomorrow I guess I'll give you a tour of all the projects I've been working on since we last worked on Narwhal, I guess.
Mm-hmm. Yeah, that'd be great. Yeah,
And
lots has happened in the years.
yeah, and and we can talk more about this. All right. Well, thank you very much.
Yes. Well, thank you for joining, and I'll be doing these every week, and I'll be putting the videos online and probably bookmarking certain sections and trying to just get in the habit of this. And then I'm hoping sort of towards the end of the year that I've actually built a little bit of momentum in these weekly groups and have a bit of a community of developers participating in the development of the system. And so, yeah.
All right. I'll talk to you later.
Okay, thanks.
Bye.
Bye. All right, so that wraps it up for today. And I'll be back online next week to go over the next aspects and any questions. And that's it.